So now we know the different types of reliability, and hopefully I've convinced you that reliability or consistency is a good thing when you're trying to measure something. So that means what we need to do is to think about what are some different ways we can improve the reliability of our measurements in behavioral science. Well, there's a few things that we can do. We can never guarantee good reliability, but we can always try and take steps to make sure that our measurements and our results are as consistent as possible. The first is through clear conceptualization. That is, thinking about exactly what is the construct that we're trying to measure and making it as specific as possible. Okay, that's going to help us create a great operational definition and therefore a more reliable one as well. A second is a process called standardization. Now, this is a process by which what you can try and do is to make sure that there's reliability or consistency across either different items or across different raters. For example, if what you're going to have is multiple people observing and rating behavior, such as the Olympic judges, what you hope that they do is become trained in exactly how they're going to go about doing this. Okay, so just like when we're doing grading in a course, there's a lot of different people that are going to grade different elements and products that you're producing here in this exact course. Well, what we've done is we've had sort of a training workshop for the graduate assistants and had them go through a process whereby we're using a consistent rubric to grade your assignments and making sure that we're all applying that same rubric consistently. Just like the judges have to go through a training session in the Olympics to make sure that they understand how many points to award for different types of different actions or behaviors that the gymnasts and divers are producing. So standardization is another great way to try and achieve consistency, especially across different raters. Another thing you can do is to simply increase the number of items. If we're trying to measure intelligence by asking people one question, that's not going to produce as consistent or reliable an estimate as if we ask them 10 questions, and that still is not going to produce as reliable an estimate as if we ask them 100 different questions. Now, of course, there's going to be a trade-off in the number of questions that you can ask people and expect them to complete in your study, and increasing the reliability ad infinitum just to try and improve reliability. You can also use a more precise measurement instrument. We talked about measurement scales in the last lecture, and we saw how there's increasing precision across those different scales. That is, a ratio scale is the most precise measurement that we have, rather than an ordinal or an interval scale, for example. So if what we're asking people to do is to respond to certain items, one thing you can do is to try and garner those measurements and those responses on the most precise scale of those that's available to you. That is, if developing a ratio scale is an option, you're going to want to try and do it as opposed to um, uh, a, a less precise scale, such as an interval scale. Another way to think about this is, again, using the analogy that we can draw to measuring physical quantities. If you have a ruler that measures in inches and you try and measure the length of something, okay, if it falls between 3 and 4 inches long, then you're going to have to either round up or round down or just guess somewhere in between. However, if you measure the exact same thing in millimeters, now because millimeters are smaller, that is, millimeters is a more precise measurement scale. Now you can have much less error. For example, if you have 2 or 3 different people measuring the same thing, if it falls between 3 and 4 inches, some people might guess, oh, it's about 3.5. Some people might round up to 4. Others might round down to 3. But if you use millimeters, then let's say it falls between, 2 different values on the millimeter scale, and I can't do the conversion in my head right now, but the point being, hopefully you understand that in this situation, people who are using the millimeter ruler are going to have more consistent measurements. It's all going to fall right around the same value for millimeters as opposed to measuring something in inches. So using a more precise measurement instrument is another option to improve consistency or reliability. Another thing is to use multiple indicators. So rather than just having one specific measurement of a construct, such as a judge's rating, okay, or just a self-report, what you might use is multiple different ways to indicate the same sort of thing. So when we talk about something like anxiety, we might use one type of measurement, such as self-report, but we might use something else, such as nervous tics or things that have come up in class that an observer might be able to rate, in addition to something like physical quantities, like heart rate, perspiration, some of these other things. So by combining multiple different indicators of the same construct, then we increase the reliability and consistency as well, because chances are, even if one of them might be a little bit off, that by using multiple indicators, we're ultimately coming up with a more reliable, a more consistent measurement. Okay, finally, and we're going to talk about this in action when you guys are developing your own surveys, is looking at doing what we call pilot testing and as well as replication. So if you think you have a good instrument, then the best way to figure out whether or not it's in fact reliable is to do what we call pilot testing. That is, go out and actually use the instrument and then see if it's reliable. So again, we've talked about we can use correlations to calculate things like test-retest reliability or split half reliability. What you can actually then do is to use your instrument, measure these things, and then see if it doesn't produce the type of reliability or consistency, high enough correlations that your research that you think it demands. Then what you can do is to just adjust the instrument and then go out and test it again. Now, of course, this is quite time consuming, but again, this is the best way, especially for important or enduring instruments such as personality scales and intelligence tests that are in use today, the SAT and the GRE and other aptitude tests that are in use today. All of these have undergone extensive pilot testing, replication, and revision in order to become sort of the standard instruments that they are today. In addition to a lot of these other properties as well, they've gone through a process of standardization. They all carry a large number of items and so forth and so on. So now let's move along to our next concept, that is validity. We've talked about reliability, and we've talked about it in terms of the consistency of our measurements. Well, validity measures whether or not we're accurately measuring the thing that we're supposed to be measuring, as opposed to something else. So again, in a word, if we think about reliability as the consistency of our measurement, then validity you can think of as the accuracy of our measurements. Now, there's a number of different types of validity we can talk about. Jackson talks about several, and we're going to introduce several in the lecture here now as well. Now, again, this is one point where there's a bit of a departure from Jackson's coverage and my coverage, so make sure you pay close attention, especially on the last two measures of validity that we're going to talk about now. So first of all is what we call content validity. Okay, now remember, all of these are thinking about different types of accuracy. Content validity, what we want to know is, does our instrument include all of the right items? So let's say, think about the first quiz you guys are going to have in a couple weeks in this course. Okay, well, if what I want to do is to measure your knowledge of all the course concepts we've covered up to that point, which is what you hope an instructor or professor wants to do on a quiz, then content validity, that quiz will have content validity if it includes all of the right items. In other words, if it spans all of the coverage that we've looked at during these first few weeks of the course, that is all the material up to that point, then it would have good content validity. If instead, let's say every item on that quiz talked about material we covered in just the first week, then it's going to have low content validity because it's not including all of the different things that it should be including to measure knowledge in the first few weeks. Okay? Or if you think about something like intelligence as a broad construct, then it should represent several different types of intelligences. So if instead it just focuses on one specific type of intelligence, like verbal ability, then it's not going to have good content validity for measuring the broader construct of intelligence more broadly defined. A second type of validity is what we refer to as criterion validity. And Jackson breaks this down a little bit further, and you can read in Chapter 3 how she does so. The main thing that we're interested in criterion validity is whether or not our instrument accurately predicts or forecasts. Okay? In other words, if I have an instrument that supposedly is measuring anxiety, then people who score high on it, I should be able to predict that if I put them in a situation that they're going to be very anxious or act very anxiously. If I give an instrument that says that somebody is intelligent, then I hope that they're making intelligent decisions, and I hope that I can predict that people higher on this instrument or higher on this test are indeed going to produce more intelligent decisions in different situations. So your instrument has criterion validity if it can predict some sort of outcome measure. Third is what we call construct validity. Now, construct validity is sort of a global or catch-all type of validity, and it simply says, is it measuring the correct construct? That is, if we're trying to measure something like intelligence, are we indeed measuring intelligence and not something else? Okay, for that reason, construct validity oftentimes is broken down into two different types of validity. Now again, pay attention here because this is not covered in Jackson's Chapter 3. In particular, to establish the broader notion of construct validity, does my test or my scale or my measurement, does my operational definition of this variable indeed measure the construct that I think that it measures? Or is it in fact measuring something else? That's what we're talking about with construct validity, and we can establish this two ways. The first is through what we call convergent validity. Okay? We call it convergent validity because what it means is if there's some other way to measure the construct in which we're interested, we want that instrument and our new instrument to converge and produce similar scores. So in a sentence, convergent validity talks about whether or not our measurement agrees with other related measures of the same or similar constructs. So let's say I develop some new intelligence test that I want to go out and market. Well, one way that I'm going to establish construct validity, that it in fact measures the construct of intelligence, is to see whether or not it agrees with current well-established measures of intelligence, such as the Wechsler test or IQ test. Well, a similar and complementary type of validity to think about establishing construct validity then is what we call discriminant validity. So not only do we want our new test to measure intelligence, we don't want it to measure everything else as well. That is, does it discriminate among unrelated measures? Maybe our test does indeed measure intelligence, but it's also measuring a lot of other things besides intelligence. So in order to measure the correct construct, we want our measurement to measure the thing that we do want to measure and not measure things or record things that we don't want it to measure. Now, there's an easy way and a very common analogy to think about how we think of reliability and validity. In particular, there's a metaphor, thinking about using a bullseye or a target. Okay, and you'll see this metaphor a lot. If you Google reliability and validity, it's going to be one of the first that you see, I'm sure. Okay, if you think about the target construct, okay, then what we're really trying to do is we're trying to measure this unknown construct, this psychological construct. Okay, and we've talked about how difficult that can be when we're talking about, the human psyche and human behaviors. So we don't really know what we're aiming for here, but as with any sort of bullseye, we want to be aiming towards the center. In particular, what's a perfect situation for us when we're measuring the construct? Let's say we're taking multiple measurements, either with multiple items on a scale, or multiple different raters rating the same thing, or multiple different instantiations of a test across the same person or across different people. What is it that we're hoping to achieve? Well, an ideal situation is that we're hitting the bullseye every time. Okay, so that every single item is measuring the construct that we want to measure, or that every single judge is giving the score, an accurate score in terms of what we want to achieve. Well, then we can think about reliability and validity in terms of how well we are hitting this target, how well we're meeting this goal. So if we're in fact, every time we measure something, hitting the bullseye, okay, then note two things here. First of all, we're hitting the bullseye and we're doing so every single time. Hitting the bullseye is an indication of accuracy or validity. Doing so every time means not only are we hitting the bullseye, but we're doing so consistently. That is, we also have very good reliability. So this is an example of something that's valid and reliable. You can contrast that with a situation such as this one. Okay? In this situation, what's going on? Well, we're hitting the same spot on the scale, okay? But it's not the spot we want to be hitting. So in other words, our measurements here are grouped together. Okay? So we're measuring or hitting the same part of the dartboard every time, but it's not the place we want to be hitting. So what situation is this? Do we have validity and or reliability here? What do you think? This would be a situation where we are indeed measuring the same place every time, or we're hitting the same part of the dartboard, but it's not the part we want to be hitting. So we're being very consistent, but we're not being very accurate. That is, we do in fact have reliability, but we don't have validity. Now, contrast that with another situation, such as this one. Here, now our darts are all over the place. They're all over the dartboard. On average, maybe it looks like they're kind of grouped near the center, but it's kind of hard to tell. Okay, so in this situation, what might we have? Validity and or reliability? What do you think? In this situation, we might have validity. It seems that on average, we're accurate. We're kind of averaging, if you will, these darts onto the center of the dartboard. But with such low reliability, because they're scattered all over the place, it's kind of hard to tell. And finally, you can think about a situation such as this one, where not only are our measurements all over the place, but even on average, they're not really even in the neighborhood of where we want them to be. Okay? A situation where we lack both reliability and validity.